In this section, we're going to talk about how to add in the pitch and roll controls we discussed earlier. It'll involve a bit of math, but thanks to the source math library, it won't be nearly as bad as it could be. The first thing we want to do is to make the controls register, and to do that, we're going to want a new function. We'll call it jets parse controls, and we'll give it an integer I buttons, and since we're probably going to need to know about the frame time, we'll put that in as well. That should be good enough. Now let's go and put a call to it right where we want. Now for our control system, we're going to parse the controls and then run all of the thrusting functions. So I'll put the function here. I'll pass it I buttons on frame time. Good. Now then, the next thing we need to do is implement it. Put it right here. Void C prop Jeep jet parse controls. Now we're going to have some if statements to check against I buttons. Now for the forward and back, left and right controls, we can use the usual WSAD configuration. So we'll have in forward, and then we'll have some others. And to look up which ones you want, simply check in buttons.h. You've got a full list. We're going to be using in forward, in back, move left, and move right. So we'll copy this. And we'll change which key we check for each one. Now it's time to make these conditional statements actually do something. Now remember, the idea behind our control system is we have an up vector that we're going to rotate around to change our goal orientation. If we rotate it around the car's forward vector, we'll roll. If we rotate around the car's side vector, we'll pitch. But we want all of these transforms to take place in the world coordinate system, so we're going to need to find what the car's forward and side vectors are in the world coordinates. And to do that, we'll create a couple of vectors that we're going to fill. We'll call one the pitch axis, and we'll call the other the roll axis. And we can fill them by making a call to get vectors. Now, the forward vector would make us roll, so we'll call that the roll axis. And the right-hand vector will make us pitch, pass in that. And we don't need anything for the up vector. Now that we have all of this, we're going to need to figure out how we're going to rotate our goal axis about one of these axes by some number of degrees. Now, if you think about it, that's an operation that only requires 3 arguments and would probably be well suited to a function, so let's create it. We don't actually need it to be a member function either, so we'll just create the function rotate vector about axis. We'll pass in a reference to the vector. We'll pass in the axis to rotate it about. And we'll pass in the degrees to rotate it by. And the next thing to do is to figure out which math functions we need to use. And if you recall, there's a vector rotate function, but it requires a matrix. So let's create a matrix. Call it, and we're going to fill it using a math function that you can find by digging around some in the mathlib.h file. It's called matrix build rotation about axis. And it takes in the axis to rotate about, pass it the axis, the degrees, and the matrix to fill. So we have the rotation matrix. Now we just need to rotate our vector, but we also need to create a temporary vector which will store the result of the rotation operation. That's all ready. Vector rotate. We're rotating our toRotate vector. We're rotating it by the rotation matrix. And we're filling the answer into vec_out. And finally, we're setting toRotate equal to vec_out. Now, you might be tempted to pass toRotate into both arguments here, but unfortunately, due to the way the function works, you can't. So temporary variable is our best option. Now that we've created this, let's go back into the parse control functions and add in our calls. Rotate our vector about the axis. We're going to use mWorld goal axis. Now if you recall, we want to pitch forward when we press forward. So we're going to use the pitch axis. And we're going to want a negative number because by the right hand rule, that will take us forward. We'll just enter -90, and then we'll multiply it by our frame time so that we will have a rotational control speed of 90 degrees per second. Now, constants are bad, so we're going to define ourselves one more console variable, gjet control, and we'll give it a default value of 90, which is what we were using originally. Now we'll scroll back down to function we want. Gjet control dot get float, and with this function call we can just copy it, this is about the same axis in the opposite direction. Now we'll use the right hand rule again, and we'll say if we want to roll left or right, we know we need to roll around a forward pointing vector, which is our roll axis. And if we want to move left, we know we need to move in the negative direction. And if we want to move right, we know we need to move in a positive direction. There's one last thing we need to do. Now that we have control over our up axis, we need to be able to reset it. Every time we turn the jets back on, we don't want to revert to the last orientation we had, so we're going to need to initialize it every time we turn the jets back on. We'll set mWorld goal axis back to its original setting of 0, 0, 1. Save that. Build it. Turning the jets on, we see we've got very powerful steering. Unfortunately, we also notice that we're going to need to reduce the power of the jets and increase the power of the stabilizer. Let's fix those default values. Put the jet power down to about 14 and increase the stabilizer to full 360 for now. And we can tune these variables later. We also want to decrease the power of the steering a bit to something more reasonable, say about 60 degrees per second. And finally, an SVN commit.